All right, take a look at the notes. We're ready to go. So let's take a look here. And we're starting off, and again, there's always a method to my madness, why I put it in the homework, why I did a warm-up yesterday. Again, it's because I have your best interests at heart. It says recall. To simplify, a radical means to not leave a radical in the denominator. Okay, so you can't have a radical and a square root I use interchangeably. No perfect square factors under the radical. And I think it would help us if we write down something. Perfect square numbers. So do this at the top. Perfect square numbers are numbers like 1, 4, 9, 16, 25, 36, and they go on infinitely many times. So when I say to you, no perfect square factors under the radical, that means I can't leave a factor of 4 underneath, I can't leave a factor of 9, and we'll kind of go over that in a little bit. And no fractions under a radical. So in example 1, if I have the square root of 28, so I'm hoping, based on what I did in the warm-up yesterday and on your homework, I'm hoping you guys are in way better shape than if I hadn't. 28 is 2 times 14, and 14 is 2 times 7. The 2 2's are prime, and 7 is prime. I have a pair of 2's, so this would simplify as 2 square root 7. Now, just like I really emphasized to you with check your work when you factor, you want to just pause a moment and check. 7 does not have a 1 or a 4 factor in it. You don't check anything bigger than 7. But do you see that 4 doesn't go into 7, so I know I'm done. In letter B, so this one had a perfect, that's what I mean by no perfect square factors. There's a 4 goes into 28, so that's not okay. In letter B, the problem is there's a radical in the denominator. So we're going to do what's called rationalizing the denominator. And what you do is you just multiply by the radical in the denominator. So what ends up happening is I get 2 square root 5 over, and initially you get the square root of 25. But what is the square root of 25?
5.
It's 5. So that's why you do that. And I skip this middle step, okay? I don't write it down because I know square root 5 times square root 5 is 5. Now the problem with letter A was there was a perfect square factor of 4 underneath there, so it wasn't simplified. Letter B, the problem was there's a radical in the denominator. And C, the problem is you're not allowed to leave a fraction under a radical. But we have something called the quotient property for radicals, and I can split this into the square root of the top divided by the square root of the bottom. Well, the square root of 1 is 1, so I can kind of tidy that up. And then now I have the problem from letter B where I have a radical in the bottom. So I multiply by radical 3 over radical 3, and that leaves me with radical 3 over 3. So I went ahead and did this because you did this in Algebra 1 and Geometry, but I wanted to bring it back because we need this. So everything that we're doing, everything that you learn, it comes back. And so it's really, really important that you don't just learn and dump. We need to make sure we learn and really completely understand. So now we're ready to get to our Algebra 2 stuff, and I think that you did this in Algebra 1. You tell me when we get there. It says the square root method is another way to solve quadratic equations. The first 2 days of this, solving quadratics, what was the method you just used the last 2 days? We said solve the quadratic equations by
0
factoring. Okay, the first method we did was factoring. And so what's going to get tricky here is we're going to end up with like 5 methods. And you need to then figure out which method is the most convenient. Some methods don't work, and some work all the time. I'm going to show you each technique, and then we're going to press pause and look at, okay, which one do I choose? So here we go. This is really important. And if you'll put a little box or a circle around this, if x is an algebraic expression and s is greater than 0, s greater than 0 means it's positive, then x squared equals s has two real number solutions, the square root of s and the negative square root of s. Note, x squared has to be alone. So look at this first little example. If x squared is 9, my two solutions are plus or minus 3. Because I did the square root, but I've got to remember that there is, in fact, a negative root that works. Like a negative number, when I square it, is 9. So in the next one, if x squared is 7, I'm doing plus or minus the square root of 7. I did it mentally on the first one, and I already knew what it was. All right, so here's the big idea. Okay, step 1, isolate the squared term. Write this down so this will help you when you're doing this technique. Step 1, isolate the squared term. So it's not always x squared. It could be parenthesis x plus 2 squared or x minus 5 squared. Take the plus or minus square root and then solve. Okay, this second step is going to be really, really important. So what I want you to do, every problem, and we're going to get through number 8, okay? We're going to do 1 through 8 together, going through this process, then I'll give you some time to practice on your own. But I want you, all 8 times, and every time on your homework, I want you to read through the 3 steps. If you do that like 12 times, you'll have the steps memorized, okay? So step 1, isolate the squared term. So Hannah, is the x squared alone on the left side?
Yeah.
Yes. Then Ellie, what is step 2?
Take the plus or minus of the square root.
All right, I'm going to do plus or minus, and if you have a calculator, if you don't know this one, what's the square root of 144, Josh? 12. Okay, and then I'm done because that was it, okay? Number 2. All right, Edward, what does isolate the squared term mean in number 2?
Get x alone.
Okay, so how would I do it?
Divide by 2.
Good. Do you understand, guys? 2x squared is not this. These are not the same. So this is x squared equals 36. And then Safe, what was step 2 again? Plus or minus, and I know the square root of 36, that's 6. All right, note, x squared has to be alone. So Brooke, in number 3, what do I do first as my first step to get x squared alone?
You isolate the squared term.
Okay, so what do I do first?
You subtract the 2.
Good job. All right, you're going to subtract the 2. And I get 25x squared equals 9. Then Sophia, what is my next step?
So, wait,
No, I mean in this problem. I'm not done with step 1 yet. I'm still trying to isolate.
take the square root.
No, I can't do that yet, Mia.
Divide 25.
Yeah, okay, so Sophia, when we say step 1 is isolate the squared term, that means I need to get x squared alone. I'm not ready for step 2. So my step 1 took more than 1 line, okay? So this is giving me x squared equals 9 over 25. If it helps, guys, put plus or minus and do the square root symbol. If you can do it mentally when they're perfect squares, terrific. If you need the extra step, do the extra step.
Oh my goodness.
All right, number 4. Negative 3x squared equals 21. So I'm going to divide by negative 3. And I want you to write this down on your paper. For now, what we know is a number times itself can never be negative in our real numbers. So this one is no solution, but I need to tell you something. Later in our chapter, we're going to learn about a new number system called the complex numbers, and they include something called imaginary numbers. So we're going to eventually be able to solve these, but so far in our chapter, you cannot get x squared equals a negative, okay? All right, now let's move it up a level in number 5. Step 1 is isolate the squared term. Do you understand that x minus 2 is something squared? Okay, now I'm ready to go. This is going to be x minus 2 equals plus or minus the square root of 5. Okay, because I have my something squared. And x minus 2 squared is not x squared minus 4. That's not true. I add 2, and I get x squared, not x squared, sorry, that's an x, equals 2 plus or minus the square root 5. Sorry, that's just an x, and I can't erase because it's going to erase my whole board, and I don't want that. Now, radicals need to have like terms in order for us to be able to combine them. So my answer is just 2 plus radical 5 and 2 minus radical 5. Do you understand that's 2 answers? That's 2 separate answers. All right, number 6. I'm trying to get the x minus 1 squared alone, so I'm going to add 6. So step 1, get my, and that's why I didn't say x squared. Do you see what I wrote down? I said isolate the squared term. So sometimes it's a quantity. Now I'm going to do the square root. So it's plus or minus square root 25, which I know that, that's 5. Now watch this one. If I add 1 to both sides, this is 1 plus or minus 5. The difference between 5 and 6. In number 5, I had a square root with a number and I can't combine them. But in number 6, can I add 1 plus 5?
Yeah.
I know what that is, right? So if you can compute it, you're going to compute it. 1 plus 5 is 6, and 1 minus 5 is negative 4. All right, when you're ready, flip the page.
Wait, negative 4?
I did 1 minus 5.
Wouldn't that be a positive 4?
No, I'm taking away 5. I only have 1, and I'm taking away 5. All right, again, we're going to get to number 8 and stop. But number 7, I'm going to divide by 10, and I get x minus 7 squared equals 44. All right, now we're going to combine this with all the stuff that we've done so far. So this is x minus 7 equals plus or minus the square root of 44. Uh-oh. And I haven't intended to gloss over it, but do you remember our opening simplifying radicals? All radicals must be simplified. I can tell 4 goes into 44 11 times. So what I'm going to encourage you to do is don't do it here, but off to the side, do your 2 times 22, 2 times 11. So always check that your radicals are simplified. So this one has a pair of 2's. So I'm going to multitask and do 2 things here. I'm going to add 7, and I'm going to simplify the square root of 44 as 2 square root 11. So let me pause a moment and see how we're doing with this. All right, I did the plus or minus, and I think we're okay with 7 plus or minus square root 44, but you've got to remember to check your square roots to see if they can be simplified. All right, number 8. What do you do if the number out front is a fraction? If it's a fraction, you just multiply by the reciprocal. And the reason why is the 5's cancel. So don't let it bother you if there's a fraction in front of the squared term. To clear a fraction, you multiply by the reciprocal. Because think about it, like if I took 2/3 times 3/2, that's 1. 4/5 times 5/4 is 1. Alright, now I take the plus or minus square root, and then I add 4. Before you circle or box it, stop and think. Can my radical be simplified? No. Can I combine those? No, they're not like terms.